Okay, welcome to Statics and Mechanics of Materials. In today's class, we are going to continue the discussion that we started in last class. Remember the God equations of statics? Summation of forces is equal to 0. Summation of moments is equal to 0. Now, in this particular problem, what you have is you have a roller, and roller will always give you vertical reaction. So you will have AY, which is the vertical reaction given by the roller. You have a hinge. Hinge will give you a horizontal reaction and a vertical reaction. So you are going to have something like BX and you are going to have BY. And in this problem, it is asking us to find out the reaction AY, BX and BY. So in this problem, they are asking us to find the reactions BX, BY and AY. So equation 1, summation of forces in x direction is equal to 0. Can you see the only force in x direction is what? Bx. So this is going to be minus bx. Why is it minus bx? Because you have x and you have y. So bx is going in the negative x direction. Summation of forces in y direction is equal to 0. Now what are the forces in y direction? You have AY, you have BY, both of them are positive, and you have minus 450. Okay. Now we have to apply the last but not least, summation of moment is equal to 0. Now I want to ask you a very important question, and please pay attention. Since this truss, it means multiple members connected together, that's a truss. Since this truss is in equilibrium, not going anywhere, no matter wherever you take movement, it's going to be 0. So you can take movement at A, you can take movement at B, or you can take movement at C. You can take movement at D. You can take movement anywhere. Summation of all the moments is going to be 0. But use your sharp mind and tell me, to minimize the work, where should I take the moment? Where should I take the moment? B. Why do I take the moment at B? Because at B, there are two forces. As soon as I take moment about B, moment given by Bx and moment given by By, I don't have to worry about it. Everyone understood this? So these two forces are acting at point B. So I'm going to take summation of moment at point B is equal to 0. Now curl your fingers in the direction of moment. Moment given by AY. Can you see moment given by AY is negative? So AY times 5. Moment given by 450. Curl your fingers in the direction of moment is positive. Plus 450 times 3. And B1, and then there is one more moment, which is 600 Newton meter. That is just a movement. You are not going to multiply that by 2 or 3 or 4. Everyone understood? Because it's a movement. Curl your finger in the direction of movement, and that movement is plus 600. So solve this, and you get answer for AY, which is 450 times 3 plus 600 divided by 5. And from that, you'll be able to find BY. What is value of AY? 390. value of by is 60, and value of bx is equal to 0. Any questions here? Pretty simple stuff, right? Next problem is even simpler. So this is called as the hold on clamp. So what you have is you have this clamp. This clamp is actually fixed here and here. So there are two locations that this clamp is fixed. So basically what this is saying is this is the pivot point A, and it says it applies compressive force. Now I want you to understand. This is the clamp. This is the clamp. Now this clamp is going to exert compressive force on the block. So this is the block. So you have this block. And on this block, this is going to apply compressive force of 400 Newton. Now this block is resting on this platform. This block is in static equilibrium, which means the platform is going to give you 400 Newton going like this. You agree with me? Now there is this screw, and this screw, I have drawn the free body diagram. So force on this screw is going to be 400 Newton in upward direction. So what this means is when you combine everything together, you are only left with 400 Newton. And now what you have is you have this bolt here, which is B, and there are two bolts. So I'm going to call this FB. I'm going to call this force FB. And these bolts, they pivot about this point A. So the forces, if you want to take the moment about A, summation of moment about A is equal to 0, you are going to have the moment that is given by 400 Newton. The lever arm given by 400 Newton is 150 plus 250, which is 400. And that is cancelled out by the force in bolt. But there are two bolts. Remember, there are two bolts. So if you look at the front view, if you look at the top view, you're going to find one bolt here, and you're going to find one bolt here. So there will be two forces. So summation of moment is you have 400 Newton multiplied by 400, and that will be cancelled by 2 times FB times 150, and that will give you the force in each bolt. Please try to understand. Moment given by this force will be cancelled by the clamping force on each bolt. Moment given by that force will be cancelled by clamping force in each bolt. So you solve this equation, and then you are going to get FB is equal to 533 Newtons. So you are going to get this would be the answer. Now let's solve the next problem. In the next problem, what you have is this is called as the butt joint. This is called as the lap joint. Wherein what you have is you have one plate, you have drilled holes, you have one plate on the top, you have one plate at the bottom. So the central plate, the middle plate, is kind of sandwiched between these two plates. And this plate has some bolts. So in this problem, what they are asking, determine the maximum force P the connection can support so that no slipping occurs between the plate. And they are saying there are 4 bolts that is that are used so that and each is tightened so that it is subjected to the tension of 4 kilonewton. Coefficient of static friction between the plate is 0.4. So let me show you the top view. So what you have is, you have this plate, and on this plate there is this load P by 2, and then you have this plate, and then what you have is there are 4 bolts. You have 4 bolts, and since there are 2 plates, the force P is acting on the green plate, and P by 2 are acting on the red plate. Now the idea is, you don't want any slipping. So the total force, the normal reaction on each bolt is 4 kilonewton. So you have 4 bolts. So the total normal reaction is 4 times 4, which is 16 kilonewton of normal reaction that is acting on this bolt. Now we know that coefficient of static friction. So if we looked at this in last class, if your normal reaction is N, coefficient of friction is mu. If your coefficient of friction is mu, the frictional force F is mu times N. Frictional force F is equal to mu times N. So if you look at the coefficient of friction 0.4, normal reaction 16, so the frictional force that is going to resist the motion of this plate, frictional force that is going to resist the motion of this plate is going to be 16 times 0.4. So it will be 16 times 0.4. So it will be F is equal to 16 16.0.4. Kilonewton. 6.4 kilonewton. So 6.4 kilonewton force, and please understand there are 2 friction surfaces. You have a frictional surface here, and you have the frictional surface here. So there will be 6.4 over here. There will be 6.4 over here. So total force P is equal to 2 times 6.4, which is 12.8 kilonewton. So this lap joint will be able to support maximum amount of P as 12.8 kilonewton. So 12.8 kilonewton on this side and 6.4 kilonewton here, 6.4 here, 6.4 here, and 12.8 kilonewton over here. So this is the maximum force that this can withstand. As soon as your P exceeds this 12.8, the block will start sliding. Any questions? Okay. Next problem. is very interesting. In this particular problem, what you have is you have a block that is traveling on a ramp. So what you have, if the coefficient of static friction between the incline and the 200-pound crate is 0.3, determine the force P that must be applied on the rope so that it can start moving. Now, this problem talks about a rope and pulley arrangement. Please understand, a rope and pulley is a simple machine. Simple machine means a device that gives you some type of mechanical advantage. Now, what type of mechanical advantage do we get here? Now, I want you to look at how this pulley is constructed. So, you have this pulley. One end of the pulley is over here. And then what you have is, you have one rope over here, other rope over here, and you have P over here. So what's going to happen is this rope is going to pull in this direction. This rope is going to pull in this direction. And then you are going to have the P acting on this side. So whenever you have a configuration like this, you get something called as mechanical advantage, which means the total force which is applied here is P and P, which means what's going to happen here is you are going to have P here, you are going to have P here. So because of the pulley arrangement, you are going to get the mechanical advantage. Because of the pulley, you are going to get mechanical advantage. Now, energy can neither be created nor be destroyed. So, where is this mechanical advantage coming from? Now, please try to understand. If I pull in the horizontal direction by 1 meter, if I pull the top rope in horizontal by 1 meter, both these small ropes will get pulled by half a meter. So, in other words, the energy that I'm spending, the work that I'm spending, force times the distance, is P times 1. But now the mechanical advantage is I get force amplification, but the displacement reduction. Everyone understood this? So this is acting like a lever arm. So you have a lever. And if you have 100 newtons here, this distance is 5. Then I can have 50 newtons here, but this distance has to be 10. Do you agree with me? What it means is 50 newtons of load is able to support 100 newtons of load at a larger lever arm. In other words, the work done by 50 Newton is equal to the work done by 100 Newton. Only difference here is 50 Newton, your displacement will be twice that of 100 Newton displacement. What does that mean? Which means, imagine if I somehow this gets like this. This angle is theta. This angle is theta. If this distance is L, do you agree with me? This distance is going to be 2L. Do you agree with me? So what has happened is I have gotten mechanical advantage. In other words, I got force amplification. But even though I got force amplification, the work that I did is the same. Work is same as energy. Energy can neither be created nor be destroyed. It can only change form. This is exactly same as you have an internal combustion engine in your car. Initially, engine is generating same amount of power. Initially, you have more torque but less speed. And as you go on to the second gear, third gear, fourth gear, the torque gets less, but the speed increases. Do you understand this? So that's why all of a sudden, if you have to go up time, you have to climb the vehicle. Vehicle needs to go up, you downshift because you need more torque. So energy is remaining the same, but torque and speed they change. Similarly, force and displacement relationship changes, but at the end of the day, you get a mechanical advantage. So a lever or a pulley is called as a simple machine. Why simple machine? Because basically, in essence, it's a mechanism. We'll study about mechanisms a lot in RAS 230. And it's basically a mechanism is used to transmit forces to get a mechanical advantage. That's why it's a simple machine. Everyone understood this? I want you to be absolutely clear. Because of that pulley arrangement, you are actually getting twice the applied force on the block. Everyone understood this? This is an extremely important observation. Because of the force P, you are getting 2 times force P on the block. So you are pulling the block with 2P. So if you basically look at this incline, which is 30 degrees, on this incline, there is this block. And here, what you have is you have 2P, because 1P here, 1P here, and then you have the weight. So weight is 200 pounds. Weight is going to go down 200 pounds. Then what you have is you have the normal reaction. Normal reaction will always be perpendicular to the surface. And then you are going to have a component of self weight going in the downward direction. So this is 200 pounds. The normal reaction is going to be 200 cosine theta. So this guy is going to be 200 cosine theta, cosine 30. This guy will be 200 sine 30. And the frictional force is going down is F is equal to mu times N. Mu is 0.3. N is 200 cosine 30. So, and then you apply summation of forces in x direction and y direction is equal to 0. This is y, is x. Summation of forces in x direction is equal to 0. 2p, which is minus 2p. Then you have the component of weight, which is going down, which is plus 200 sine 30. And then you have the coefficient of friction multiplied by the normal reaction, that is again going down. Cosine. So you solve this and then find out the value of P. And if you do this calculation quickly, you can tell me what is the answer. So 200, so this guy is a normal reaction. Normal reaction is always perpendicular to the surface. Normal means perpendicular. Reaction means force. Normal reaction. Okay, what is the answer? Okay, one word of advice. This sheet only includes about 16 problems, but the handout that I have uploaded includes about 30 problems. So the remaining problems are homework. Okay, so work out all the problems that I have given in handout. Okay, P is equal to what? 76. Here is the next problem. You have this automobile. The weight of the automobile is 2 megagrams. 2 megagrams is 2000 kilograms or 2 tons. The mass center is at G. Now, this is a very important concept because the next chapter that we are going to study is called as the centroid. Centroid is the imaginary point on that figure where the entire mass is located. So what it means is if you have a rectangular figure, the centroid is going to be at the center. If you have a circular figure, the centroid is going to be at the center. If you have a triangular figure, it's going to be at 1/3 from the base. Similarly, if you look at this vehicle, inside the vehicle, the mass is never uniformly distributed. Engine is heavier. That's why you can notice that the center of gravity is lean towards the front. Center of gravity is lean towards the front. It's not at the center. Now, this is very important concept. And understand, I don't know if you have seen the older vehicles, older cars. There are two types of brakes. One is a disc brake and other one is a drum brake. Drum brake is like you have a brake drum and you have the brake shoe that clamps the drum. Think like a bicycle brake, but so you have a disc brake and you have a drum brake. Disc brakes are always more efficient. It means the braking power that is provided by the disc brake is more than the drum brakes because of the geometry. And we'll talk about it. That's why if you see most of the mountain bikes, they do not have disc brakes. The street bikes, they have sideways clamping disc brakes, drum brakes. So basically the wheel rim acts as a drum and you get the brake shoe that clamps onto the wheel rim. So this is the drum brake. The disc brake is you have a disc that you see in a motorbike, you have a disc in the bike and basically you clamp the disc and that is more efficient. If you look at the older vehicle, for example, I had a 2003 Nissan QX4. The front brakes were disc brakes, rear brakes were drum brakes. And the reason for that is typically you add braking power where you have maximum normal reaction. In this particular case, since the CG of the vehicle is towards the front, when you take the moment, you realize the normal reaction is going to be greater at the front wheel. That's why you will have a lot more traction at the front wheel and you use disc brakes when you need more efficiency. Nowadays, if you look at the car, most of the cars, they have disc brakes. But if you look at some older cars, they have disc brakes in front, drum brakes in rear. And I will work out one more problem on disc brakes, drum brakes, so that will be clear. But in this particular problem, it is asking, find out the towing force that is required for move the car if the back brakes are locked and front wheels are free to roll. So in this particular problem, what you have is you have front wheels and you have rear wheels. front wheels can roll. Once something starts rolling, the coefficient of friction is very low. But the back wheels are a brake. So basically, you are sliding the back brakes. That's not a very good idea if you ask. But the way this problem is set up is the front wheels are free to roll. It means the friction is zero. So think about it, no friction. And here you have max friction. And then what you have is you have 2000 Newton here. So 2000 times 9.81. This is the weight of the vehicle. And then what you have is you are going to have one normal reaction here. You are going to have one normal reaction here. And then what you have is you are going to have a force, a towing force, which is F. And this towing force will have two components. Since theta is equal to 30 degrees, you are going to have F cosine theta, and then you are going to have F sine theta. So what we need to do, you have an A, you have NB, and since NB is the normal reaction, mu times NB is the frictional force. So once again, understand the setup of the problem. What you have is, you have this vehicle, the front wheels can roll freely, no friction, the rear wheels are locked, so you have friction, and then there is a force which is at angle F. Then you resolve the force along the x-axis, along the y-axis, and now we have set up a force system and we apply conditions of equilibrium. So I apply summation of forces in x is equal to 0. So this is x, this is y. When you apply summation of forces in x is equal to 0, 0 is equal to minus f cosine 30. Then you are going to have another horizontal force, which is plus mu times NB, which is the frictional force. This is frictional force. Then we will apply summation of forces in y direction is equal to 0, and forces in the y direction is you are going to have plus f sine 30. Then you are going to have plus an A, you are going to have minus 2000 times NB, 2000 times 9.81, and then you are going to have plus NB. So you have F sine 30, you have NA, and you are going to have NB. Last but not least, you have to take moment and then summation of moment. Now tell me, where would you take moment? What would be a good place to take moment? I'll give you choices. You can take moments at point B. You can take moments at point A, or you can take moments at point C. You can also take moments at point D, because wherever you take the moment, conditions of static equilibrium will be satisfied. Summation of moment is going to be 0. Tell me, looking at the setup, where would you take the moment? Which would be the easiest? You can take moments at B. So now what you have is, let's start. So you have F cosine theta, curl your fingers in the direction of movement, F cosine 30 multiplied by 0.3. This moment is positive. Then you have F sine 30, curl your fingers in the direction of movement, minus F sine 30. And this distance is 1 plus 1.5, 2.5 plus 0.75 is 3.25. Then you have the moment given by NA. So curl your fingers in the direction of moment given by NA, minus NA multiplied by 2.5. And last but not least, you have the moment given by the weight of the vehicle, which is plus 2000 times 9.81 times 1.5. You agree with me? Now understand, let's identify the number of unknowns. Mu is given to us, 0.3. So the unknowns are F, NB, and NA. So again, F, NB, and NA. So in this particular problem, there are 3 unknowns and you have 3 equations. So you should be able to solve this set of equations. Everyone understood this? So just out of curiosity, if I give you a problem like this, how would you solve? Correct? Now you see there are 3 equations and there are 3 unknowns. F is an unknown, NB is an unknown, and NA is an unknown. The first equation gives you the relationship between F and NB. Second equation gives you the relationship between F, NA, and NB. And the last equation gives you the relationship between F and NA. Are you with me so far? I want you to follow. Now, first thing, whenever you have system of equations, what is the systematic way of solving this set of equations? If you have studied matrix algebra, then you can express into the matrix, find the inverse, but assuming you haven't taken linear algebra. Let's look at these equations. And can you observe that first equation has NB and F? You agree with me? Second equation has NA, NB, and F. You agree with me? And the third equation has F and NA. Does it make sense? So this is the strategy I'm going to use. I'm going to find out NB in terms of F. So I'm going to find out from the first equation. NB is equal to F cosine 30 divided by mu, which is 0.3. Do you agree with me? From the last equation, I'm going to find out, can you see F? So I will have this F in the parentheses, cosine 30 0.3 minus sine 30 times 3.25 minus NA times 2.5 plus 2000 times 9.81 times 1.5. Can someone quickly tell me what is this value? Can someone tell me what is this value? F times 1.36 minus NA 2.5 times NA. And can you tell me what is this value? One 29,450, right? Third. Now, what I can do is I can find out NA is equal to 29,430 minus 1.36 F 1.36 F divided by 2.5. You agree with me? So now check this out. I have this equation for NB. I have this equation for NA. So this NB equation, I will substitute here. And this NA equation, I will substitute here. So which means after I substitute NB and if I substitute NA, the only unknown that is remaining in that equation is F. So you can get the value of F. Once you get the value of F, you can get value of NB and get value of NA. Everyone understood this? So this problem is a little bit tricky because there are three unknowns and three equations. So you need to use appropriate substitutions so that you can get the right answer. So you will solve the first equation, express NB in terms of S. Solve the third equation, express NA in terms of S. Substitute NA and NB in the equation 2, which means the entire equation will be in terms of F. And then solve for the value of F. Any questions? Okay, next problem. So this is the drum weight problem. I don't know if you notice what you have is you have this drum and on top of it there is this brake shoe. So you have this brake shoe. So what you have is you have this is the brake shoe. And what happens is when this brake is applied, this gives a normal reaction N. When you have a normal reaction, please notice the drum is trying to rotate in this direction. So the frictional force will be in this direction, which is mu times N. And the frictional torque, so frictional torque, frictional force is going to be mu times N. Frictional torque is equal to mu times n multiplied by the radius of the drum. So this is R, n times R. So how do these drums break drum work? I don't know. Have you seen the dyno testing on the cars or dyno testing on the wheel? If your vehicle is 1996 or before, you go for emission, they put your vehicle on a chassis dyno and basically load your vehicle and capture the emissions. So think about it. What happens is you have this drum that is rotating. You press that brake or the shoe hard onto the drum. As you press harder, the normal reaction would increase. And what happens is, if you increase the normal reaction, the coefficient of friction multiplying the normal reaction, frictional force also increases. And at some point, the torque given by the frictional force cancels out the torque given by the motor, and the drum stops. So that is the principle of drum brakes. So you have the frictional force, which is mu times n, and mu times n, frictional torque is mu times n times R. So the drum would stop when external moment m is equal to torque because of the frictional force. M times mu, m is equal to mu times n times R. Now, if you look at the free body diagram of this, if you look at the free body diagram of the lever, if you look at the free body diagram of lever, on this lever, you are going to have a downward force P. The normal reaction is going in this direction. So the force here is going to be N. This distance is going to be B, and this distance is going to be A. So if you take moment about C, summation of moment at C is equal to 0. So you will say P multiplied by A. Curl your fingers in the direction of moment, is positive, minus N times B. So this is the principle of the drum brake. Now what happens is, you have that lever, you press the lever, which means apply more P, you get more N. Why do you get more N? Because there is already a lever arm. A is greater than B. So if you apply P is equal to 100, AB ratio is 1.5, N is going to be 150. Then you are going to get the frictional force N multiplied by mu, and N multiplied by mu times R gives you the reaction force. This is a very important problem. Have you seen, if you look at the farm tractors, have you seen they have big wheels? Why do they have big wheels? They have big wheels because the lever R value is greater. When R value is greater, even though the weight is the same, coefficient of friction is the same, the traction increases. That's why you have these large agricultural tractor wheels. They go from muddy or maybe loose soil, where if you have a small wheel, it may not be able to go, because the frictional torque, mu times N times R, R is greater, mu is constant, N is the weight of the tractor. So that is how you get more traction. Now I'm going to give you this problem for the homework, which is P. And this is an important problem, because try to understand, this is a simple machine. And let me explain how this simple machine looks like. So what you have is, you have a pulley here, you have a small pulley here, And then what you have is you have a pivot point over here. So what you have is you have the first rung of the pulley that attaches over here. This goes over here, and then this goes over here. So if this is AT, please note you want to draw the free body diagram. So let's understand you have pulley A and you have pulley B. Let's look at the forces on pulley A. The rope has 80 pound here. For pulley to be stationary, to satisfy the conditions of equilibrium, it needs to have 80 pound here, which means here is going to have 160 pounds. Then what's going to happen is, if you look at this pulley here, so what you have here is you are going to have, so this, and then you are going to have pulley like this. So you are going to have 80 and 80 on either side. So you are going to have 80 here. So draw this free body diagram, and remember, because of the pulley, you get mechanical advantage, and then this problem is similar to the plate problem that we have solved. Okay, this is a very important problem. Now, before I solve this problem, I want you to understand that this is called as a truss. Why it is called as a truss? Because remember, this is one link. This is another 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 link. And all these links are pinned. All these links are pinned. And whenever you want to solve a truss problem will ask you to find out forces in each link. Whenever you are trying to solve a truss problem will ask you to find forces in each link. Now what I'm going to do is, just for my own satisfaction, I'm going to assume this to be 100. I'm going to assume this to be 100, and I'm going to assume this to be 100. Now, one thing that I want you to note, that there is a hinge on top. Whenever you have hinge, that means you have a horizontal force, AX, and you have a vertical force, AY. And secondly, what you have is you have a roller. Whenever you have a roller, you have only one force, which is perpendicular in this direction, which is I'm gonna call B. If I want to solve a truss, I want to find out the reactions at the support. How do I find out the reactions at the support? Or we can take a moment. So this guy is going to be B cosine 45. This guy is going to be B sine 45. Do you agree with me? Summation of forces in x direction is equal to 0. So what are the forces in x direction? I have AX, which is minus AX. and I have minus B sine 45. Do you agree with me? Summation of forces in y direction is equal to 0. So let's look at the forces. I have 100 newtons, which is going down, minus 100. I have 100 newtons going down, minus 100. I have 100 newtons going down, minus 100. And then I have two forces which are going in the vertical direction. First one is AY, and second one is B cosine 45. Do you agree with me? Now please try to understand how many unknowns do I have here? I have three unknowns: AY, AX, and B. It means I need one more equation, and that equation is going to be summation of moment is equal to 0. You can take moment anywhere. You can take moment at point A. You can take moment at point B. You can take moment at point C. You can take moment at point D. You can take moment at point E. You can take moment anywhere. Now, what I want you to tell me, look at the problem and tell me where should I take the moment to make my life easier. Let's see. If I take moment at A, okay, if I take moment at A, my AX and AY, they cancel out. You agree with me? I don't have to worry about moment of AX and AY. If I take moment about B, then my B cosine 45, B sine 45, they cancel out. So it doesn't matter whether I take moment about A or I take moment about B. The maximum number of forces I'm going to cancel out, there are two. So I can take moment about A or I can take moment about B. Tell me, where should I take moments? Now, one thing I want you to understand, as soon as I resolve this force, okay, as soon as I resolve that force, now I have these two components of B, B cosine 45 and B sine 45. That inclined force B has been resolved, that no longer exists. Don't take the moment of B sine 45, B cosine 45 and B, because B is the resultant of B cosine 45 and B sine 45. You agree with me? Everyone understood this? So I will take moment about maybe A. Moment about A is equal to 0. So moment about A is 100 times 6, curl your fingers in the direction of moment, plus 100 times 4 plus 100 times 2, and then as you can see, B cosine 45 goes through point A, so no moment. B sine 45, curl your fingers in the direction of moment, minus B sine 45 times 2. So I solve this and I get value of B. And value of B is going to be 100 times 6 plus 100 times 4 plus 100 times 2 divided by 2 sine 45. And that gives you the value of force B. Once you know value of force B, you can find out the value of force AX, and then you can find out the value of force AY. Tell me, what is the answer for B, please? 848. What is the value of AX? What is the value of AX? AX is equal to minus B sine 45, so which is minus 848 sine 45. And why is it minus? That tells me that the direction that I have assumed is incorrect. So incorrect direction. So AX is in this direction. So this is how the AX should be. And what is AY? AY is equal to 300 minus B cosine 45. Are you with me? Okay, the last part which I want to talk about is if I want to find out the forces in this member, if I want to find out the forces within truss, how do I solve? So let me set up the problem. So what you have is you have this truss. Then you have this. You have this. And then you have this truss. And we have found out the forces here. We know what this is. 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 Now here, the force is 100. This distance is 2. This distance is 2. What I'm going to do is, I'm going to go joint by joint. So check this out. I'm going to look at this first joint. And this first joint is C, D, F. So this is, and I'm going to look at this joint, C, CF, CD, and the force which is acting here is 100. Now, this distance is 2. This distance is 2. Which means both these angles are 45, 45. This is 45, this is 45. You know why those two angles are 45? Because the two sides are equal. So this angle is 45 degrees. If I have a downward force going in this direction, you agree with me, the force in CF should be upwards and force in CD should be towards left. Why is it like this? Because check this out. This horizontal force cannot cancel the downward force. The downward force will only be cancelled if you have some force in the vertical direction. So this link, which is at angle 45 degrees, this is the link, only link that can provide vertical force. And since you have this inclined link, it's going to have a horizontal component that would be cancelled by this. So this force is going to be FCF, and this force is going to be FCD. I apply summation of forces at joint C is equal to 0. Summation of forces in the x direction is equal to 0. So I have FCF cosine 45 minus FCD is equal to 0. Can you see that FCF, if I take the cosine component of it, FCD is going towards the left-hand direction. And summation of forces in the y direction is equal to 0, which means 0 is equal to F. So 100 is going in the negative direction, 100 plus FCF sine 45. So from this equation, FCF sine 45, 100, can you see the only one unknown is FCF? I can find out the value of FCF. Substitute the value of FCF in this equation and you get the answer for FCD. Everyone understood this? Now, please note, I solved this force, I solved this force. Now, what I'm going to do is, I'm going to solve this joint, joint D. Then I'm going to solve this joint. And then I'm going to solve this joint. That way, I can find forces in this entire truss. You agree with me? This is called as the method of joint to solve the truss. This is called as the method of joints to solve the truss. Now, I want to give you a very simple thing here. If you look at the last joint, this joint is A. If you look at the last joint, you have AY, you have AX, and then here you have 1, 2, and 3. Remember, method of joint only deals with forces. So I should not try to attempt to solve AY because there are 3 unknowns: force in this member, force in this member, and force in this member. So I should not attempt to solve this joint, but I can definitely try to solve this joint. You agree with me? Joint B has one horizontal member that will cancel out the horizontal force, and then we have one vertical member that is cancel out the vertical force. So next chapter is solving trusses. So next week we'll finish trusses. So again, use the God equation of statics and solve truss.